Good afternoon, everybody. Dear authors and invited guests, welcome to the technical session 4B. My name is Siddhi Avdi, and I'll be moderating today's session. On the behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the 8th International Conference on Information and Communication Technology for Intelligent System, ICTIS 2024, Ahmedabad, India. The 8th version of the conference is being organized in hybrid mode. The physical event was organized in Ahmedabad, India on 4th April 2024, and the virtual event is being held through Zoom meeting today on 5th of April. I hope you all will enjoy today's session. It will be knowledgeable and interactive. And in this session, we will in total have 10 presentations, and each presenter will be given a time span of 8 minutes. And 2 minutes will be reserved for question and answers. So I request all the participants to please keep a note of the time constraint. And I will be raising a gentle reminder after 7 minutes. And there is also another request for all the participants that you stay connected with us till the very closing remarks because we have some instructions to give at the last. And if you face any query or have any issue, you can write it to me in the chat box. I'm here to help you. Now, just before we get started, I would like to introduce you all. Anisha, can you please change? To today's session chair, Dr. Varsha Damodar Zadav. Varsha ma'am is currently working as an assistant professor in Artificial Intelligence and Data Science Department of Vishwakarma Institute of Information Technology, Pune, India. She completed her PhD in computer engineering from Dr. Babasaheb Ambedkar Marathwada University, Aurangabad. She has 19 plus years of experience in teaching. Ma'am, thank you so much for joining us today.
Thank you. Thank you, Siddhi, very much for the pretty introduction.
Okay. So the next presenter is Mitali Chaudhary, ma'am. Ma'am, are you present with us?
Yes, I'm present.
Would you be able to present right now?
Yes.
Thank you, ma'am. I'll stop sharing my screen and then you can proceed with your presentation.
Yeah, sure. Hello, is my screen visible?
Yes, ma'am, your screen is visible.
So, good evening, everyone. My name is Mitali Chaudhary. Our project title is paper title is Enhancing PETCare through Petri, a machine learning based comprehensive framework. Our paper ID is 122. So, these are the contents of our presentation. Moving on to the abstract. Pet adoption addresses the urgent need for animal to find loving home while also easing the burden on overcrowded shelter. Petri, a cutting edge by leveraging advanced technology like convolution neural network. Petri not only identifies crucial details about pet but also connects user with adoption centers. Envision a future where technology plays a pivotal role in reducing pet homelessness and fostering stronger human and animal relation. Moving on to introduction, Petri is an innovative platform that leverages machine learning to transform the pet adoption process. The platform utilizes advanced machine learning algorithms for recommendation, dynamic data analysis based on customer feedback. Hence, this creates a prime experience for users. Customer feedback is transformed into actionable insights through the use of data analysis tools. These insights are then presented in user-friendly dashboards, enabling adopters to easily access and interpret reviews, thus facilitating informed decision making. This website caters to novice pet adopters that means new pet adopters who encounters a pet on the road and wish to explore adoption. It envisions a future where technology plays a crucial role in reducing pet homelessness, increasing adoption rates, and strengthening the human-animal bond. This is a literature survey. The first paper we referred was titled as Animal Welfare and a Health Abided System. These were the key findings that are the paper underscores the creation of unified system for animal welfare, stressing the importance of merging technology with online resources for comprehensive management. Uh, the researchers created a website as a central hub for pet owners, and their website also serves as a knowledge hub, providing articles, guides, and expert advice on pet care topics like nutrition and behavior training. The technology stack that they used was HTML, JavaScript, and CSS. The year they published was 2021. The second paper we referred for literature survey is an analysis of machine image featured extracted by CNN to design classification model for COVID-19. So the main key findings were this study showcases the effectiveness of deep learning techniques. Also, the study highlights CNN capabilities to extract intricate features from medical image, enabling accurate classification models and stressing advanced image analysis in medical imaging. The technology they used was CNN, TensorFlow, and HIPAA. The year they published was 2020. The third paper was titled as Pet Adoption App. This was a basic app by harnessing the researchers harness the power of mobile technology. The creators aim to address the critical pet over population. The app encourages responsible pet ownership and fosters a community passionate individual dedicated to animal well-being. The technology was Shutter and PostgreSQL, and the year was 2022. The problem identified our create this project was basically potential adopters lacks knowledge about the specific feature and characteristics of cat and dogs, hindering their ability to make informed adoption decisions. Making individual may desire to adopt a pet but have limited or no prior experience with these animals, leading to uncertainty and potential mismatch between pet and owners. There is a need for accessible and accurate pet related information to support potential adopters in making informed decisions in the era where pet ownership is on the rise. This is a solution proposed. We have a home page for user where the user registers firstly, and secondly, after registration, the user logins. Then after coming onto the home page, we the user will see six main services of our website, that is locations, which consist the available locations where the pet adoption centers are available. The next service is adoptions page, where the users need to add a image of the pet. The CNN will classify the pet's breed and will fetch the shops where the breed is available. The next is shopping services, basically the accessories for dogs like food, clothing, uh, uh, toys, etc. Then after adding to cat, we can make payment. The next is training, where our website is integrated with many pet trainers, where they educate the pet new pet owners. So this that contains online pet care videos or a personal trainer. The personal trainer will view online videos, will share online videos, or can personal physically train your pet. The next section is veterinary doctor. Uh, if your dog is not well, the adopter can get appointment on our website and visit the doctor based on the appointment dates. Next services in NGOs. The NGOs alert the NGO about criminal act, any violence seen by any user can fill the form and about violence, and the connected NGO will rescue the pet. This is our project flow diagram where user interface has chatbot system where a basic chatbot will answer your queries. Then we have CNN where the user will upload photo of any found pet which he desires to buy adopt. Then the uploaded image will go for processing, and after processing using CNN algorithm, the breed will get fetched, and after getting the breed, the from the database, the shop will be suggested to the users. This is our system architecture. The web application is made using HTML, CSS, JavaScript, and Flask. When connected to internet and is also connected to database. Database is created using PHP and XAMPP server. The database is through the internet. When the user uploads or image or visits our website, will get connected to the database, and the database will go to the machine learning app when the user uploads the photo, fetching the uh, pet breed using CNN algorithm. The user can get the out. The use case diagram. This is our use case diagram for user site, where the user visiting on our home page can adopt pet, can shop for pet, ask queries to chatbot, access training programs. They can book appointment for doctors. They can give feedback. They can upload the image of the pet, and for shopping they can add to cart, and after which will extend to buy products. Now for
Extremely sorry to interrupt you in between. Actually, we have passed the presentation time. So can you please conclude it in a minute or something?
okay, just a second. Uh, s- uh, So this is our algorithm which we used in this. There are 7 layers which we are using. That is input layer, CNN layer, cooling layer, flattening layer, and fully connected layer, and output layer. So this is basically, in short, is when the user uploads a photo. Uh, when the user uploads a photo, the CNN algorithm works and fetches and identifies the breed of the pet. So this is our main homepage. Okay. So these are the 6 services which we are providing. When the user clicks on adoption page, these are the pets available for adoption. When the user clicks on pet care services, these are the sample training videos which they can refer. When clicked on doctor doctor services, this is a home page for doctors where the user will fill this form, and this is for NGO. This is our NGO page, and this is a basic chatbot for customer queries. So here, this is the GUI for where the user inputs the image, and this is the predicted breed where basically now it's only one breed in the database, where only one shop having this English foxhound, so it is just suggesting one shop only. So concluding towards this, Petri offers a solution to the challenge of informed pet decisions, enhancing the welfare of both pets and pet owners. So using CNN, we have Petri streamlines the adoption process, promoting responsible pet owners and reducing pet overpopulation. Expansion of Petri capabilities to include other types of pets, a broader geographical coverage, and can extend its impact on animal welfare and adoption rate globally. This is our future scope. And these are the references which we would used for our project. Thank you.
Yes, Mitali, it was a very interesting topic and very nicely presented. Yes, my question is like, you are giving the database of the dogs which are available in the shop.
Yes,
But yes, my question is, what about the roadside dog? If a photo of a dog who is at the roadside is given and given by the shop owner and told to purchase that dog, so how that could be identified?
hello. Can you please
Yes,
repeat it? Hello.
yes, it's about the roadside dogs. Can you hear me?
Yes.
About the roadside dogs, if the photograph, that is image of the roadside dog is given, only viewing at that image, how can the customer identify whether to have that dog as a pet or not?
Ah, if a user is uploading an image, the breed will be classified, and we have collaborated with the NGOs. So when any street dog uh, street dog's image is clicked and uploaded, the NGO which has has the dog can be connected,
Okay,
can get connected.
many of the dogs, they look similar.
Yes,
In that case, how the algorithm differentiates the images?
the features of dogs, like there are minute changes every dog has. So the CNN algorithm will work on it and then will give output. Find the breed of the dog.
Okay, nowadays Gen AI generated images are in boom.
Yes.
So generative AI images
Hmm.
are in boom. So
Yes.
if a picture generated by AI,
Hmm.
it cannot differentiate between real and fake. Yes. So in that case, have you thought about something like that? Because your paper is actually not containing this point. I'm just giving you some more points to work on.
Okay, we will think about it.
Yes.
Yes.
Okay. Thank you very much, Mitali. Very nice.
Thank you, ma'am.
Thank you so much, ma'am, for your presentation. Now all the questions are done, so we'll proceed to the next presenter. Now we have Vidya, ma'am. I think they fixed their issue of mic. Uh, so they will be presenting next.
Ma'am, can you hear me, ma'am?
Yes, ma'am. You are audible now. Ma'am, I've stopped sharing my screen. Now you can present.
Hello, everyone. My name is Vidya Kurani. I'll be presenting on our work and exploratory analysis of deep learning models for detection of lung cancer in medical images. This is the outline of our presentation. We'll start by introducing our research topic. Then we'll look at dataset description, then related work, problem statement, objectives, implementation, extreme learning machine, gray level co-occurrence matrix, results and analysis, conclusion, and references. The lungs are the primary organs of the respiratory system. The lung is said to be affected by cancer when abnormal cells grow in an uncontrolled way in the lungs. Lung tumors can be either malignant or benign. As per World Health Organization, lung cancer is the leading cause of the cancer-related deaths worldwide, accounting for the highest mortality rates among both men and women. Early stage lung cancers they're often present with few or no symptoms, making it challenging to detect in its initial stages. Lung cancer is often diagnosed at advanced stages when the treatment options are limited. So timely diagnosis and treatment are crucial for improving survival rates. The dataset description, the dataset has been taken from the Kaggle. It contains a large number of CT scans of patients diagnosed with lung cancer in different stages, as well as the health subjects. These are the few images of benign, malignant, and normal images of lung cancer. Coming to the related work, many researches have been done in the field of ELM. Here are some of the researches that have been done in the past, which discusses about extreme learning machine outperforms traditional methods for multi-class classification, about its scalability and its faster learning speed. The problem statement is to develop an efficient multi-class classification system for diagnosis of lung cancer using extreme learning machine algorithms applied to a diverse data set of medical images with the goal of improving easy detection and classification of lung cancer subtypes. Objectives are to design and implement a robust ELM-based model for the automatic classification of lung cancer subtypes using medical images. Assess the classification accuracy and computational efficiency of extreme learning machine model in comparison to established benchmarks. Coming to the implementation part, the first step begins with defining the problem. Then the data collection, the data has been taken from the Kaggle. Next step is data pre-processing, where resizing and normalization operations are performed on the images. For pre-trained models, feature extraction is done by pre-trained model themselves. And for extreme learning machine model, the features of images are extracted using gray level co-occurrence matrix. For the distances 1, 2, 3 and angles 0 degree, 45 degree, 90 degree and 135 degree, GLCM is calculated for all combinations of distances and angles. Various statistical features like contrast, energy, homogeneity, correlation, and entropy are extracted from the GLCM. Then random weights for the network are initialized. The neural networks are trained using the training data. Then it computes the training and testing accuracies. Then finally, the results are analyzed. Excuse me. Extreme learning machine is a feed-forward artificial neural network. It does not require iterative training or tuning of weights and biases to achieve high accuracy. It uses an analytical solution to calculate output weights. Training process is fast. The key idea behind extreme learning machine is to randomly initialize the input layer weights and then analytically determine the output layer weights using a single pass through the data. This means that the training of an ELM model typically involves only one forward pass through the network, making it very efficient, especially for large data sets. Architecture of the ELM, it consists of 3 layers: input layer, hidden layer, and output layer. Input layer receives the input data. Hidden layer consists set of randomly generated weights and biases. The complexity of the model, the precision of predictions are influenced by the number of hidden nodes. More the number of hidden nodes, better the accuracy. But more complex the model becomes. Output layer provides the predicted values. It has number of advantages such as computational efficiency, simplicity, scalability, generalized performance, robustness to overfitting, versatility. As the training involves a single pass through the data and analytical determination of output layer weights, it results in computational efficiency. ELM has a simple and straightforward training procedure, hence it's simple. Then it also scales to large data sets because of its single pass training. Despite its simplicity, ELM can effectively learn from data and generalize to unseen examples, making it a reliable choice for many practical applications. Random initialization of input layer weights and fixed hidden layer activation functions can help prevent overfitting. ELM can be applied to a wide range of machine learning tasks, including regression, classification, clustering, and dimensionality reduction. This is about the gray level co-occurrence matrix. It is a texture analysis technique used to characterize the spatial relationship between the pixels. It is performed on grayscale images. It calculates how frequent the pixel I occurs either horizontally, vertically, or diagonally to adjacent values with value j. Direction of analysis can be done either horizontally, vertically, and diagonally. Coming to the results and analysis, as we have seen, like in ELM accuracy graph, training accuracy, initially the training accuracy is 93.1%. and test accuracy is 87.27%, indicating good pattern of learning and generalization. The model seems to generalize to test data effectively without memorizing the training set. In VGG16 accuracy graph, both training and validation accuracies rise, implying learning complex features. Training set performance peaks at 85.6% accuracy, while validation stabilizes near 81.5%, possibly indicating a generalization limit. Increasing disparity between training and validation accuracies, especially in later epochs, hints at potential overfitting. In ResNet 50 model accuracy graph, it starts with an accuracy of around 60.5% and achieves 76% validation accuracy. Despite some significant loss, ResNet 50 shows strong learning capabilities. The validation accuracy exceeding 97% indicates satisfactory performance. In VGG19 model accuracy graph, the model's validation accuracy is 71.2%, training accuracy is 51.5% initially. Despite a significant loss, the model learns continuously, showing promising improvement in training and validation accuracies. A high training accuracy suggests the model could overfit, capturing the noise in the data. These are the graph of comparison and table of comparison. From the graph of comparison, it can be inferred that ELM, when compared to other models, it is lighter since it has fewest parameters. ResNet 50 has the maximum number of parameters, followed by VGG16 and VGG19. Considering the time consumption, ELM consumes shortest time compared to other models. For testing accuracy, ResNet 50 with 97.07% exhibits highest level of generalization to previously unknown data. ELM exhibits strong performance as well. Testing accuracies for VGG 16 and 19 are lower compared to ResNet 50 and ELM. Conclusion. ResNet 50 attains 97.05% accuracy but requires more time and uses more number of parameters. VGG 16 achieves high accuracy but shows overfitting with increased gap between training and validation accuracies. VGG 19 exhibits divergence between training and validation accuracy, suggesting overfitting. ELM achieves 93.82% accuracy with less time and parameters. ELM serves as a valuable tool, particularly for tasks where computational efficiency and simplicity are crucial considerations. However, the choice of best model depends on various factors, including the specific requirements of the task, available computational resources, and the trade-off between model complexity and performance. These are the references. Thank you for giving me an opportunity to present in this conference.
Yes, thank you, Vidya ma'am, for your very nice presentation. And my question is, with the existing system, have you compared your work
Compared the work with
the existing
system?
Yes.
No, ma'am, we haven't compared. But
so that comparison should be done. And how more efficient your system is should be analyzed.
Like we are comparing the models, ma'am. ELM model with the traditional models.
Yes, definitely. Yes, you're comparing the models. It's really very good.
Yes.
But there are also few existing system which predicts the lung cancer. And
Yes.
nowadays, generative AI, it is predicting the cancers 6 years in advance.
Yes, ma'am.
Yes. So how can you prove that your system is more efficient than the existing one? That should be analyzed.
Yes, definitely we'll analyze it, ma'am.
Yes. And one more thing is that what is the future work scope of your work?
Actually, now the accuracy of ELM is less compared to ResNet 50. So we are planning to improve the accuracy for some more extent.
Okay, fine. I would like to suggest to go for Gen AI.
Yes,
because that will give you more accuracy.
Thank you, ma'am.
As compared to the traditional machine learning and deep learning methods.
Sure, ma'am.
Yes. Thank you very much.
Thank you, ma'am.
Thank you very much, ma'am. Now we'll proceed to the next presentation. So now we'll proceed with the Prashant sir's presentation, which is the paper titled Automotive Radar Data Communication and Simulation Using ROS. Sir, are you with us? So we are not able to hear you actually.
Am I audible right now? Good evening, everyone.
Yes, yes, you are.
Yeah, sorry for that. So, may I share the screen?
Yes, I'll stop sharing mine. So please make sure the time constraint is of 8 minutes. So try to wrap it up in 8 minutes.
Yeah, sure, I'll try my best.
Thank you.
Mm. Yeah, so good evening, everyone. I'm Prashant, and I'm presenting our work on the automotive radar data communication and simulation using ROS. And in the rapidly advancing field of autonomous driving technologies, the demand for more reliable and robust systems for sensing different parameters had witnessed a certain approach, particularly the reliability and precision for sensing the objects and their parameters like relative position, distance, etc. in different weather conditions increases the requirement of such systems. So in response, a comprehensive framework that not only ensures reliability and precision, but also provides visual insights into the monitored area with scalable features has become necessary to build a and prominent prototype and develop prominent perception-based autonomous applications. Thus, our proposed framework provides an efficient way to simulate the communication of an edge radar sensor with the ECU electronic control unit, which is further responsible for further actions based on the perceived data using the robot operating system. And using the ROS, we have built a two PC communication model that will achieve the following. We defined the two PCs, that is the Linux machines, that is PC1 and PC2. PC1 will send the data to PC2 either using the publisher server or the client server model. The data sent by the PC1 contains an array of structure called location underscore list of size number of locations with structure with structure as shown below. Single location has the radius, azimuthal angle, and elevation angle. And so here is the radar module and edge radar sensor through the Ethernet. The data is sent, and the data is converted from the spherical coordinate system to Cartesian coordinate system. And through the Wireshark tool, we are validating. And the received data is can be visualized using the point cloud. That is ROS visualization using the point cloud. And this left half process happens in the PC1 and the right half process happens in the PC2. And the network setup, we have used Ethernet cable to set up the network between two PCs. We have assigned the IP address of 10.0.0.1 and 10.0.0.2. Yeah, the same has been shown over here. The algorithm includes the four five phases. The first one is the data generation, where we generate the data. Then the data has to be communicated, data communication, and then we transform the data, and then we visualize the data, and then we verify the data. And so for our reference, we have used the radar sensor of Bosch. We have considered the mid-range radar sensor. So it has the range of 160 meters and the mid elevation azimuthal angle of 42 degrees and the elevation angle of 6 degrees. And so the uh, we have used the distribution for generating the data, that is the normal distribution, and the central limit theorem. And this is because the central limit theorem, it states that the average of large number of independent and identically distributed values will be approximately normally distributed. And the distribution varies as per the mean and the standard deviation. So we set their values based on the mid-range radar sensor as mentioned. And so we are passing these parameters for the range and the uh, azimuthal angle and elevation angle. And the data, to communicate the data, there are two models. The one is the publisher subscriber model. In that, there are two nodes: the publisher node and the subscriber node. And uh, the publisher publishes the data, publishes the information or the data to a topic, and the subscriber node subscribe to that topic. And whenever the data is sent, the subscriber node receives the data. And here in this server client model, the PC2 requests a message, PC2 requests a message, and PC1 receives the request message, and then the server sends the response to the client. In the data transformation, the PC1 sends the data which is in the spherical coordinate system. Then in the PC2, it is converted to the Cartesian coordinate system, and hence we have used the computation formulas as mentioned, as seen here. And for the data visualization, the Cartesian coordinates, then they are sent to the point cloud, and to the point cloud, the you can see the visualization. And this is the demo of the. So this is the launch file you have written, and whenever you launch the node, this is the publisher subscriber model. Whenever it starts publishing, and then at the PC2, we can see the data is received and it is the visualized. And here we have set a parameter to set the number of points. So based on the number of points, the points in the radar RVIS tool, it's changed. And this is the same using the client server model. And in the data verification part, the source is the source PC1 IP is 10.0.0.1 and destination PC2 is 10.0.0.2. And here we have set the number of location as 1. So in that case, the data size will be in byte, that is 20 bytes. Header size is 8 bytes, and transmitted data size is 12 bytes. That is in float T2, that is radius, azimuthal angle, and elevation angle. Here the transmitted data was radius equal to 2 and the other two values were randomly generated. So this 4-byte floating point number will be arranged in the little endian format as shown below. So this is the radius, this is azimuthal, and this is the elevation. So for example, in order to visualize the existing data set, we the stick high resolution 2019 data set which has the 546 entries, and around it has around 10,000 radar points per frame. So its radar data includes XYZ radial velocity and intensity. We have converted the coordinates, the Cartesian coordinates, to spherical coordinates, and we have saved the data in .csv format. And this we are sending to PC1, and this converts the data. It communicates to PC2. PC2 converts it into XYZ, and then in the RVs we can visualize it. So this is the demo of it. So we have also included temperature application part where the radar sends data. PC1 has the publisher and DTC, and the PC2 as the subscriber. And we are sending the 1,000 points. We have assumed that the maximum points it can send is the 1,000 points. And then it is displayed in the RVIS. So there is a plane of points and with that intensity. So near to this, if the point is near to the plane, it will be in red, that is high intensity. As it goes far, its intensity reduces. So when the if the radar is out of its operating temperature range, and if it's overheating, then it sends to the PC1, and PC1 sends a DTC to the subscriber DTC, and then automatically the points are reduced to 500, and the plane and also the points here also are reduced, significantly reduced. Then in the subscriber part, we send a recovery action that the we have simulated that recovery action that the temperature has been reduced. And so it sends a DTC to the server, and this sends to the publisher node, and then the points drastically it exponentially increases to 1,000 points. That is max that we have set. So this is the demo of it.
Sir, sorry to interrupt you, but you'll have to conclude your presentation because the time is
Yeah,
we
in
have
a
a
few
time.
minutes I'll conclude it.
Yes.
Yeah, so we have set to increase the temperature rate by point 4, uh, and you can see that the temperature is rising, and then here you can see that the temperature it will show that the temperature is out of range or overheating. Here we can see that the temperature is out of its operating range, and then we send the recovery action, and then the points radar points, it increases as the normal functioning of the radar. So in conclusion, our proposed solution presents a robust framework for simulating the communication between an edge radar sensor and the electronic control unit in autonomous vehicles. Leveraging the robot operating system, we ensure efficient data transfer and integration, addressing the critical need for reliable object detection and environmental perception in various driving conditions. The inclusion of a temperature management system for the radar sensor adds an extra layer of sophistication, maintaining optimal operating conditions by transforming radar data into Cartesian coordinates, visualizing via the RV's ROS visualization, and implementing a publisher subscriber model. We created a seamless communication network. This contributes to perception-based autonomous applications, enhancing the vehicle safety and driving technology innovation, and it also helps in the ADAS, driver assistant. So here are some of the references that we have taken. Thank you. Thank you. This is all.
Yes,
Thank you,
Prashant.
sir, for
Yes, Prashant, it was really very fantastic work. And I
Thank you,
think you
ma'am.
have covered all the aspects in your project.
Thank you, ma'am.
I would like to ask you, according to you, what do you think are the drawbacks of your project?
Uh, Drawbacks, in the sense we haven't, done it physically. We have simulated it. So uh, one of the drawbacks might be that we have set the maximum radar points that a radar can detect is 1,000. So in the real world, that might not be the case. For a high level of safety and also to help in the other features as well, more number of points may be readed. Based on the application, the range must be increased or decreased. So that's what I was saying. We have, assume that we work on the mid-range radar sensor. So based on the application, it may be long range radar sensor or ultra long range radar sensor, or maybe the imaging radar also. So that's what I think may be a bit of drawback kind of thing. Or
Yes, yes, yes. Very good, very good. Thank you.
thank you.
thank you, sir. Now I'll proceed to the next presenter. So the next presenter for today's session is Nikita ma'am, Nikita Bhatt, and the paper they're presenting on is empirical analysis of word embedding methods for estimating their performance in vector space.
Okay. Good evening, ma'am. Today we are. Ma'am, can you please allow me to share my screen?
Yes, sure, ma'am. I'll stop sharing the screen. Now you'll be able to share your screen.
Okay, ma'am. Okay. Can you please let me know whether screen is visible or?
Yes, yes, ma'am. Your screen is visible.
Okay. Should I start now?
Yes.
Okay, so good evening, ma'am. Today we are going to present our work on empirical analysis of word embedding methods, which are going to estimate the performance in the vector space. And this is what the agenda of our today's presentation, where we are going to discuss the significance of multimodal data, which leads to the cross-modal retrieval, then the extensive literature survey we have done, objectives, then we narrow down our scope to vector space model, then we represent different ways to represent our text modality, then data set that we have used for our experiment, and at the end result discussion. So, due to growing popularity of social media, large amount of multimodal data is being generated, which is having different types, text, image, video, audio, etc. And this multimodal data can be used in various applications like hot topic detection, personalized recommendation, multimodal data retrieval. Then in web search engine, there are many applications where this multimodal data can be useful. But when we work with the multimodal data, there are many challenges involved. Among them, the first challenge is each modality is having its own representation. If we consider text, then words, phrase, and grammars play a very important role. If audio is there, then it is having its own pitch, tone, and different rhythms. If we focus on image, then it is having its own color, shape, and texture. So it is very difficult to learn a good association between multimodal data as each modality is having its own feature representation. So to compare the feature, image feature vector and text feature vector is very difficult because of the different statistical properties each modality is following. And again, from the multimodal data, the biggest challenge is to retrieve the information of interest from the multimodal representation. Due to this multimodal representation, one more kind of retrieval plays very important in nowadays era, which is called cross-modal retrieval, which says that if we give any image as the query, then my retrieval should give me either text or an image or a video or the audio. So this is what the focus, where our objective is to perform the cross-modal retrieval from the available multimodal data with the limitations of having different statistical properties of various modalities. So in cross-modal retrieval system, we are having different modality, and to bridge that modality gap during training phase, we have to generate a common space where the semantic similar information which is preserved in different modalities should be preserved. So here, once the common subspace is generated at the end of the training, during testing phase, if we give any image as the input, then my common subspace should generate the output either in form of text or audio or video. Then when we generate the common subspace, then there are two broader types. One is called real value, where real value representations are stored, and second is the binary valued approach, where we perform the encoding. Some information lost is there, but information is in form of 1 and 0. So whenever our objective is to retrieve the information as fast as possible, then binary value representation is useful. But when the retrieval accuracy, precision plays very important role, then the type of the common subspace must be real valued in nature. Then we have done some extensive literature survey in the domain of cross-modal retrieval, and we observe that in text modality, most of the work follows bag of word model as the embedding method, which has the problem of semantic meaning, which says that it completely ignores the context of the word. And sparsity is a problem because sparse vectors are generated for the large corpus, which needs more memory, and for that we need more computational resources. Other part of the domain where cross-modal retrieval focuses more, where the last layer, generally if we focus here, they share the weights of the last layer. And here, due to this real value representation, when we perform the linear search in order to perform the retrieval, then it is very time consuming. So here the goal and objective of our work is to design a cross-modal retrieval system which works on the user demand, to integrate the feature learning and common subspace generation process in the same framework. And along with that, we need to learn a good association between the bimodal data present for the retrieval, and to achieve the mean average precision better compared to the state of the methods available. So the first objective of our work is to map the words into the vector, which preserves the syntactic and semantic similarity between the words. to integrate appropriate embedding method in the existing system for better performance, and to generate the binary valued common subspace which preserves the similarity with bimodal data for faster retrieval. So in order to select the appropriate embedding method, we have explored the vector space model, and we come to know that there are two ways, two representation, local representation, and second is the distributed representation. The local representation focuses on the one word vector representation, where for each word the corresponding one value is stored, for other value 0 is stored. But here the size is very large, so we need large computational resources. Whereas distributed representation, where here from the figure we can see that semantic similar words we try to put nearer to each other in the vector space. Then local representation method we explore in detail, and we come to know that it is having various limitations of sparsity and semantic similarity. Then we go into the distributed representation, and we come to know that it depends on the distributional hypothesis, which says that words that occur in similar context tend to have similar meaning, and it must be nearer to each other in the vector space. The vector generated based on this concept called distributional hypothesis is called distributional word vectors, which are having some characteristic which says that real valued vectors that represent the word and the semantic similar words must be nearer to each other. Then there are two ways to generate this distributional word vector. One is count based, where we generate the matrix, and second is the prediction based, where the neural network is used. Again, for count based we have matrix, and second is the encoding models we can generate. We go into the detail and we come to know there are many limitations when matrix model is generated. Another is prediction based model, which follows the neural network. We thoroughly understand the each method, and this is what the challenges we have found. To select the best distributed representation method which preserves the syntactic and semantic similarity is our main concern. And we find from the literature that word2vec and GLOW have the capability to preserve the syntactic and semantic similarity. We understand word2vec, and we come to know that there are two methods, continuous bag of word and a skip gram. In continuous bag of word, the neural network tries to predict the center word given surrounding word as the input. And in skip gram, if we give any center word, it tries to predict the surrounding word. And this is what the detailed understanding of the skip gram algorithm. Then we explore another algorithm which is called GLOW, where we generate the co-occurrence matrix.
Ma'am, extremely sorry for the interruption.
Okay.
Can you please conclude your presentation within a minute or two?
Okay,
Because we
fine.
already passed the presentation time.
Okay. So this is what the data set we have used for the experiment along with the workstation configuration. This is what the result we have derived. Here different pairs of each data set we have found, and here we can observe that for each data set, GLOW outperforms over other models. Then again we select the GLOW model, and we again come back to our original problem of cross model retrieval, where our objective is image to text retrieval, and here we can see that GLOW outperforms other model. Similarly, for text to image retrieval also we observe that GLOW outperforms other model. So from the distributional representation method that we have available, GLOW, if we can select, then we can achieve the effective cross-model retrieval result. And these are the references that we have used. And these are the co-authors who is working in the domain. Thank you. Any questions?
Thank you so much,
Yes,
ma'am, for
Nikita.
your presentation.
Hello.
Hello.
Yes, am I audible?
Yes, ma'am, you are audible.
Yes, Nikita. Very good work.
Thank you.
And yes, now it is like a text to image and image to text conversion, is it?
Yes, ma'am. It is cross-model retrieval, basically.
Yes. But nowadays we are having the Gen AI systems like the Gemini and the chatbot. So would you like to compare your work with this AI tools?
And ma'am, it is a different scenario. Here, our objective is to enhance the performance of the web search engine. Like in Google also, if we give image as the query or text as the query, we have multiple different modality options available. Here, our objective is to preserve the maximum semantic similarity across the different modalities. It is different than the application that you are talking about. Domain is totally different. So our objective is not to compare our result with the other domains, but we want to preserve maximum semantic similarity between the different modalities available, and we want to put those semantic similar different modality nearer to each other in the vector space for the effective retrieval.
Yes. Okay. Thank you very much.
Thank you, ma'am.
Thank you, ma'am. Now we'll proceed to the next presentation. So the next presenter for today's session is Srinidhi Kulkarni, sir. Uh, the paper title is Harnessing DSRC for Intersection Movement Assist (IMA) in Vehicle-to-Vehicle Communication. Sir, you're with us, and I request you to present.
Yeah, can I start my presentation?
Yes, sure. I'll stop sharing my screen.
Yes.
Sir, just keep a note of the time constraint and try to wrap up your presentation within eight minutes.
Sure.
Thank you, sir.
My screen is visible?
Yes, your screen is visible.
Yeah. Good evening, all. Yes. And my topic is harnessing V2V, harnessing DSRC in intersection movement assistant in V2V communication. Here is the overview. And abstract intersection movement assistant is vehicle to vehicle communication using DSRC, which is dedicated short range communication. Is a pivotal development aimed at significantly enhancing safety and efficiency at intersections. Standardization and integration are emphasized as crucial components for the successful implementation of IMA in V2V communication. Majorly, this is implemented in the where intersection points are more. Keeping in mind those intersection movement, we have designed the safety model in V2V communication. And this paper explores the necessity of IMA in the context of V2V communication through DSRC. We are using DSRC technology here, delving into its core functionalities and the broader implications for intelligent transportation system. As intersections represent critical points in the traffic flow, the potential for collisions and complex traffic dynamics is heightened. IMA leverages DSRC to establish real-time communication between vehicles, enabling the exchange of essential information about their intended movements. This instantaneous data exchange allows vehicles to anticipate and respond to each other's actions, thus minimizing collision risks and improving overall intersection safety. By this, you got an idea like how intersection movement assist is going to work. This is an introduction part. This is our literature survey where we considered 3 papers in our work. This is a brief about those papers. And our problem statement is harnessing DSRC for intersection movement assist in vehicle-to-vehicle communication. We are using DSRC technology in this in V2V communication. These are our objectives. The main goal of intersection movement assist is to make driving safer and more efficient, particularly at intersection, as I said previously. By using advanced technologies like dedicated short-range communication, IMA aims to reduce the risk of collisions, improve driver awareness, and ensure to provide safety ride. And this is our proposed methodology. The main focus is on results. So I will go directly to the results. Here is our results to provide helper function. This is the function where we have implemented in our project. It is a MATLAB function. The provided helper function, helper plot, IMA analysis results. This is our function. Is designed for visualizing the results for of the intersection moment assistant analysis. The analysis includes several key visualization. Here are the keys like ego arrival time to intersection, target arrival time to intersection, time gap, IMA warning. Here next slide. For this, there is a graphical representation. Yeah, just okay. The uh, the ego time arrival to ego time arrival to intersection. This plot shows the arrival time of ego vehicle. Yeah, here ego vehicle represents our vehicle. Means in which vehicle we have implemented the intersection moment assist. The means we have implemented the technology to the upcoming intersection. If the ego arrival time is greater than the minimum arrival time, here you can see the minimal arrival time line is there. This is our variation related to arrival time. As you can see, if the ego arrival time is greater than the minimum arrival time, then the IMA warning is low. IMA warning is nothing but the warning, means risk warning. How much is the risk of colliding? Here you can see the intersection ego arrival time is greater than the minimal arrival time. Then our IMA warning is low. If the ego arrival time is less than the minimum arrival time, then the IMA warning is moderate or high depending on the time gap. Depending on this time gap, it would be either moderate, the risk of collision will be either moderate or it would be high. The target arrival time to intersection plot shows the arrival time to the target vehicle whose path intersects with the path of the ego vehicle in the upcoming intersection. The time gap plot shows the absolute difference between the arrival time of the ego and target vehicles to the intersection. If the time gap is less than the minimum time gap and ego arrival time is also less than minimum arrival time, then the state of IMA is high. As you can see here, it's a low. The state of warning is high, means in this point collision risk will be more. The IMA warning plot displays the state of IMA warning. This is IMA warning. This represents the risk like by indicating those colors. This is why here yellow is the low risk, orange is the moderate, and red one is the high risk. This is our results. As we have compared between the distances. In first scenario, we have compared with the 100-meter by setting the range up to 100 meters and 50 meters. How best it is going to perform between these two distances. And the second one is between 250 meters and 100 meters. And the third one is between 600 meters and 800 meters. I will read one. When the range is set to 600 meters, the plot demonstrates that the probability of detecting a packet is almost 100% up to 600 meters. As you can see here, up to 600 meters, the probability is almost 100%. It is sending the packets almost all packets. Okay. After it gradually declines, reaching zero around value greater than 1000 meters. Conversely, with a range of 800 meters, the likelihood of packet detection is nearly 100% only within the initial 800 meters, diminishing as the distance increases. Remarkably, at the distance over 1000 meters, the probability of packet detection for 800-meter range is already close to zero. Yeah, in conclusion, the intersection movement assist system is designed to enhance safety at the intersections through vehicle-to-vehicle communication. The analysis involves assessing the arrival time of the ego and target vehicles at the intersection, considering time gaps and minimum arrival threshold. And the IMA warning dynamically adjusts based on these factors, providing a reliable and providing reliable indications of potential collision scenarios. The system proves effective in preventing accidents by issuing warnings when necessary, contributing to improved safety and reduced collision risk at intersection. And this is the future scope as we have planned to implement machine learning and advanced communication protocols in this, and even HMI also. And these are the references we have referred for this project. Thank you.
Yes, thank you very much. You have implemented the thing in a prototype way, is it?
Yeah, yes.
Yes, yes. Have you thought about like the traffics which are occurring in cities like
Yeah, correct.
India, like
Currently,
Pune,
yeah.
Bangalore, Mumbai? Yes.
Actually,
So what about that?
actually, in our prototype model, we have considered roads in Americans, where the systematic traffic flow is there. Like in India, it is difficult to implement, as we can see here in India's there are many intersection roads, like wherever there are many roads from we can't imagine also from where vehicles are coming. So it's quite difficult in Indian roads. But
Yes,
yes,
and also the
it is not impossible.
roads in,
It's possible.
everywhere we can see the roads in India are having different structure. They are
Yes,
having
yes,
patches, and
yes,
at the hillside
yeah,
there is either steep or steep slope and something like this.
yes,
So if you think of all such kind of things, it would be more better, because
yeah,
it's really a very nice work,
yeah,
and such things should be implemented in India. So I think it's
yes,
smart India.
yeah,
Yes, yes. Thank you very much.
yes, sir. Thank you.
Thank you, sir, for your presentation. Now we'll go to the next presenter. So the next presenter for today's session is Monica Saini, ma'am, and the paper title is Investigation of Mean Time to System Failure of Fuzzy Semi-Markovian Repairable Redundant System. Ma'am, I request you to start with your presentation.
Okay, ma'am. My screen is visible, ma'am?
Yes, ma'am, your screen is visible.
Okay, thank you, ma'am. Good evening, all. I'm Dr. Monica Seni from Department of Mathematics and Statistics, Manipal University, Jaipur. Title of my presentation is Investigation of Mean Time to System Failure of Fuzzy Semi-Markovian Repairable Redundant Systems. These are the outline of my presentation: introduction, literature review, notations, assumption, system description, transition probabilities and mean sojourn times, mean time to system failure, fuzzy parameter estimation and numerical results, conclusion and references. In the present era of science and technology, the market value of any product or item is measured by its reliability. Reliability of any component is defined as the probability that it performs its intended function adequately for a specified period of time under the given operating conditions. The role of reliability is visualized in our daily life, from switching on the bulb to the use of car, mobile, etc. The customer expect that this equipment perform their intended function properly with full efficiency. But sometimes we found that the system or product does not able to provide the service according to our expectation. Due to the advancement of technology, all industrial, manufacturing, home appliances, and medical equipment configuration become very complex. Many researchers have recommended many techniques, many methodology for improving the reliability of these systems. It is difficult to employ the redundant system of the same configuration due to the several factors. The traditional approach of reliability based on binary assumption that the system either operative or failed, but in many systems, this assumption seems insignificant. In this scenario, use of fuzzy reliability feels appropriate. Uh, Next is a literature review. Several studies have been conducted by researchers for reliability evaluation of various kind of systems under different set of assumptions. A very few studies conducted on fuzzy reliability evaluation of non-identical units repairable systems. In this work, we investigate mean time to system failure of a standby system of non-identical units under the concept of priority and preventive maintenance subject to fuzzy environment. These are the notations which I have used in my work. K is the shape parameter of Erlang distribution, and RIT is the reliability of the system. GT, FT, F1T, F2T, G1T show the PDF with respect to the failure rate, repair rate, and preventive maintenance. These are the assumptions. The following assumptions used for development of the system model. Initially, original unit is operative and duplicate unit is in standby. No concrete failures. Switch devices and repairs are perfect. Repairman always available with system. Next is a system description. By using the assumptions, we develop or propose a stochastic model with preventive maintenance. The states described of the model is as follows. S0 is the primary functional, duplicate standby upstate, repairman inactive. S1 is the original under preventive maintenance, duplicate operative upstate, repairman busy. And S2 is the original under repair, duplicate operative upstate, repairman busy. In same manner, we use all possible cases, and here we define 12 states for our stochastic model. And next is the transition probability and mean sojourn time. By using the stochastic model, or next we calculate the transition probability based on our stochastic model. Here Q01 denotes the transition probability from state 0 to 1. And after that, we take the Laplace transformation of equation 1, and we get the probabilities. And here we verify that the P01 plus P02 is equal to 1. And this can be verified with other state also. And next is the mean sojourn time. Next, we calculate the mean sojourn time. Here, mu naught denotes the mean sojourn time of initial state. And similarly, we can calculate the mean sojourn times of other state are also can be calculated. Next is the mean time to system failure. Next, we equation 7 shows the expression for the mean time to system failure. And next is the fuzzy parameter estimation and just 1 minute. Fuzzy parameter estimation. The rate of failure, repair, and maintenance of the system followed an Erlang distribution. Also, it is assumed that the parameters of these random variables are fuzzy integrals with a bell-shaped membership function. And Temraz 2021 developed the formula that can be used to generate the intervals of the fuzzy rate parameters. And here, to arrive at an estimate value for the rate parameter, the maximum likelihood method is used. The following equation number 8 show the PDF of Erlang distribution, and equation number 9 show the reliability of Erlang distribution, and equation number 10 show the point estimate value, point estimate of Erlang distribution. The numerical value of mean time to system failure can be derived using the following step. First, we use the random sample generation. Next, we perform the point estimation. For various values of alpha cut, derive the fuzzy interval for rate parameter corresponding to various random variables. And last, we put the value of fuzzy rate parameters in mean time to system failures. Expression derived the values of mean time to system failure. First, as we discussed, first we generate the random numbers by using the Erlang distribution for our parameters. And second, table 1 show the fuzzy parameters of various rate versus alpha cut. This is the alpha cut column, and alpha is our first parameter, and this column gives the minimum value of our interval, and this gives the maximum value of our fuzzy interval. And similarly, we calculate the values for our next parameter beta, and similarly for k. And the table also show h is our next parameter. We perform same exercise for gamma and same exercise for I. Our final objective is to calculate the value of the mean time to system failure. We simply substitute our fuzzy parameter into the mean time to system failure expression, and we calculate the mean time to system failure values with respect to alpha cut set. And this column gives the minimum value of minimum mean square error, and this column gives the maximum value of mean time to system failure. Conclusion: in this study, a reliability model for non-identical units redundant system is proposed under concept of priority and preventive maintenance subject to unlock, failure, and repair loss. Generated random numbers of size 10 with a shape parameter of 3. and estimated rate parameter for all the failure and repair rates. Derive the fuzzy interval for failure and repair rates for alpha cut ranging from 0 to 1. Observe the mean time to system failure at alpha cut, and mean time to we observe that the mean time to system failure also follow the normal distribution. Results can be used in designing of non-identical unit systems, and the proposed model may be further extended to investigation of fuzzy reliability and availability. And these are the references which I have used in my study. Thank you.
Yes, good work.
Thank you, ma'am.
Yes. What data set you have used?
Ma'am, we generate data from our software, with the help of our software.
So for what particular product your data set is?
Ma'am, yes, ma'am. We,
Your
ma'am,
data
actually
set must be for some
we use
machine.
the Erlang distribution. With the help of Erlang distribution, we generate the data with the help of our software.
Data is generated, but about what product it is generated?
What product means, ma'am?
What are the different parameters or columns in your data set?
Ma'am, here we generate data for 6 parameters. For example, in notations, first parameter is alpha. Alpha is the pre-specified maximum operation time, and beta is the failure rate of original unit, and k is the repair rate of original unit. So we generate data by using the Erlang distribution, by putting the value of the parameters basically.
Okay, so you are saying that this data is generated.
Yes, ma'am.
And for what component that data belongs to?
Component.
For example, if I take a vehicle and I want to predict the reliability analysis of a vehicle, a two-wheeler vehicle. Like a two-wheeler, it is having different components into it, like the plug, it is having the motor, it is having different things involved into it. So the spare parts, they can be they are replaceable, and you can predict the reliability of those spare parts there. So in your case, about which component the data is being generated? Hello?
Hello, ma'am. I'm not getting your question.
Okay,
Sorry.
Fine, thank you.
Okay, thank you.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next presenter we have here is Divya Singh, and the paper title is Machine Learning Based Hybrid Pre-Coding for Next Generation Wireless Communication Systems, a comprehensive review. Divya ma'am, I request you to start with your presentation.
Okay, ma'am. Am I audible to you?
Yes, ma'am. And I have a request. Just keep in mind the time constraint and try to wrap up your presentation within 8 minutes. Thank you, ma'am. Now you'll be able to share the screen.
So I'm presenting here paper ID 177, and the title is Machine Learning Based Hybrid Recording for Next Generation Wireless Communication System, a comprehensive review. The content of this presentation are introduction, background, machine learning in wireless communication, hybrid recording, research summary, conclusion and references. So, to meet the growing demands for higher data rates in the wireless communication, improve reliability and increase spectral efficiency by the precoding. And precoding is one key aspect of enhancing the performance of the wireless system that increases the quality of the signal at the receiver. By using the machine learning, we can enhance the optimization process in hybrid precoding. Basically, in hybrid precoding, we have to optimize the precoder parameter, that are the baseband and RF parameters. So in machine learning, various models are used, just like DNN, CNN, reinforcement learning, and support vector machines. So basically, this paper gives the comprehensive review that what type of machine learning models we can use in the precoding, hybrid precoding, to increase the performance of the system. So traditional optimization methods encounter challenges in hybrid precoding, high computational complexity for finding optimal precoding matrix. So basically, there are three types of the precoding methods. One is the analog, digital, and hybrid. So in digital precoding, efficiency is very high, but complexity is also very high. So we can reduce the complexity by using the analog method that decreases the efficiency of the system also. So that's why hybrid precoding, we use the hybrid precoding for the system that divides the precoding process into two stages, analog and digital precoding. So this hybrid precoding is used to enhance the efficiency by reducing the hardware, that is the number of RF chains, number of mixers, converters, and all that. And it maintains flexibility in beamforming and optimization. It also improves the performance by using the efficient utilization of spectrum and enhances system resilience to interference and multipath propagation. So there are different technology in wireless communication. So number of devices are connected through the Wi-Fi. Depending on that data, from that we get the data, and the data with knowledge is applied to the machine learning concept. So depending on that, results are produced, and depending on the artificial intelligence, feedback is again sent to the machine learning that will generate the results. Now, the role of machine learning in wireless communication, it just gives the overview of the growing complexity and heterogeneity of wireless network. It is needed for adaptive and intelligent solutions to address dynamic and unpredictable environments. Role of machine learning in optimizing performance, improving efficiency, and enabling advanced functionalities. Machine learning techniques can enhance various aspects of wireless system, just like adaptive resource allocation, dynamic spectrum management, channel estimation and prediction, interference mitigation, mobility prediction, QoS optimization, security, and energy efficiency. Now, basically, the precoding is just to enhance the parameters of the precoder at the transmitter side. So just just give the strength to the transmitted signal. So as we discussed in the previous slide, there are three types of the precoding: analog, digital, and hybrid. So this is just the comparison between these three. This is the system model for the hybrid precoding. So we can see here baseband precoder, and this is the digital precoder, and this is the analog precoder, so that are used in the hybrid precoder. So the parameters of these precoders are to be optimized. That for that we will using the machine learning to enhance the efficiency, to enhance the performance of the system. So hybrid precoding offers significant benefits, but also poses several challenges. Computational complexity, hardware constraints, channel dynamics, and energy efficiency is essential for optimizing hybrid decoding. So by using the optimization algorithm in the hybrid decoding, we can work on these parameters, and research is going on to enhance these parameters or to optimize these parameters. So this paper basically gives the review of machine learning based hybrid precoder solutions. Machine learning based approaches offer promising solutions to optimize hybrid precoding for wireless communication systems. Addressing challenges and advancing research in this area will unlock the full potential of machine learning and hybrid decoding. Continued innovation and collaboration are essential for driving progress in this field. Learning complex patterns and relationships from the data. Basically, machine learning deals with the data so that are used for optimizing the decoder parameters. Automatic optimization process to reduce computational complexity. And many algorithms are used, such as neural network, reinforcement learning, genetic algorithm, PSO, and many more. This is the simply flow chart of ML based hybrid decoder design. So multi-user MIMO system is used, uh, and for that system the channel will be generated, and that will for that design we use the ML machine learning concepts. So that may be conventional cross entropy metric based hybrid decoder and weight assigned cross entropy metric based hybrid decoder. So basically this paper is the review, comprehensive review. So this table shows the summary of the hybrid decoder with different approach. So different, we can see here CNN, GAN, many algorithms are used. Different approaches are used in these papers that are discussed, that are referenced in the references. This is the comparison summary of machine learning based hybrid decoder. So that may include DNN, CNN, reinforcement learning, vector metrics, and many more, Grassman code book based. And these are the basically the comparison summary. Future work. So research is going on in this field. So that may be for increasing the performance, optimization, robustness to channel variability on the channel parameters. We can enhance the energy efficiency. Hardware implementation, we can reduce the hardware complexity, joint transmission and reception processing. Multi-user scenario, so that is basically the for MIMO systems. Conclusion. In conclusion, machine learning based hybrid decoding represents a promising approach to address the complex optimization challenges in modern wireless communication system. The current state of research in ML-based hybrid decoding has demonstrated significant advancements in improving spectral efficiency, reducing hardware complexity, and enhancing the robustness of communication systems. Overall, the ML-based hybrid decoding holds great promise for revolutionizing wireless communication systems by offering efficient, adaptable, and scalable solutions. And with the ongoing research and development efforts, these techniques are play a vital role in enabling next generation wireless network to meet the today demand of wireless systems, just like higher data rates, lower latency, and improved reliability. These are the references that are used in this manuscript. Thank you.
Yes, good work, Divya. Yes. And I would like to ask you, what are your future plans for the implementation of this decoding?
Ma'am, I just implemented the hybrid decoder. I just implemented hybrid decoder design in my PhD work, and now I will use the machine learning concept in my hybrid decoder.
Okay, okay, okay. Good. Thank you.
Thank you, ma'am.
Thank you, ma'am, for your presentation. Now we'll proceed to the next presenter. So the next presenter we have here is Prajwal GK. Prajwal sir, are you with us?
Yes, ma'am.
You may start with your presentation. I'll stop sharing my screen.
My laptop gets stuck, ma'am, so I am presenting in my mobile phone.
Yes, sir. If you're facing any issues, if you can't present, you can just send it to me. I'll present the PPT for you. Sir, this is your PPT, right?
Yes, ma'am. Yes, ma'am.
Sir, you can continue with the presentation and just tell me when you have to change the slide. I'm here only.
Okay, ma'am. Yes. Good evening, everyone. I am Prajwal from KLA Technological University, Karnataka. The increasing demand for the multi-object detection tracking, and that too in a real time, is enhancing the computer vision applications and also the hardware accelerated devices. So this paper explains the holistic approach to implement such multi-object tracker on a system hardware, that is ZCU104 evaluation kit, which is a embedded device. Can I go to next slide?
Sure, sir. Just give me a minute. Was this the next slide?
This one, ma'am.
Okay.
The problem statement which I have decided is like real-time multi-object detection and tracking on a Zinc Ultrascale plus MPSOC board. Ma'am, next. The objectives of this project includes implementing a real-time multi-object detection and a tracking system, deploying the system on target hardware, that is Zinc Ultrascale plus MPSOC ZC104 evaluation kit, and analyzing the implemented tracking algorithms. In order to do the project, various literature survey has been conducted, and the first stage of this project is to detect the objects. To do this, various algorithms are available, but the finalized algorithm is the YOLO V8, that is you only look once algorithm version 8. Based on this, based on that enhanced accuracy and speed, improved architecture and training techniques, and its cross-platform compatibility, scalability, efficiency, and its wider range of applications. Next. After the detection, the next stage is to track the detected objects. In order to do that, various tracking algorithms has been analyzed. Among them, the ByTrack algorithm is this is an universal framework which enables the integration into different MOT trackers, and this enhanced tracking consistency by using the various low confidence score object detection boxes also for the secondary association, and it prevents the loss of valuable information which is there at the low confidence boxes, and it addresses the challenges posed by occlusion and appearing changes. We can see in the figure the detected objects at the first stage will be divided into the three different categories: the high confidence score, the low confidence score, and the background boxes. And the background boxes were rejected at the first stage, and in the second stage the low confidence boxes will be considered. By doing this, we can say that it prevents the loss of valuable information from the low confidence boxes. The other algorithms does. Next slide. The next is the different algorithm, that is OC-sort algorithm, which is an observation-centric, simple, online and real-time algorithm, which is flexible to integrate with the different detectors and the detector models, and it is designed by recognizing and fixing the limitations in other algorithms like Kalman filter and sort. This algorithm is a pure motion model based multi-object tracker. Next slide. And to deploy these systems, we decided the hardware, that is ZC104 evaluation board, which is an embedded application board which has a comprehensive support for peripherals and interfaces, various embedded vision applications, and provides extensive documentation and support for the developers. And it also enables efficient utilization of resources, optimizes the power consumption and performance, which has a 4 different cores so that we can implement the parallelization also. Next. Coming to the implementation details, this is the pipeline which followed. The input frame, which will be coming from the real-time frame, and which is given to the detector models, that is YOLO V8 model. After the detection model, we should go to the tracking algorithm, but the important step here is the model conversion. Like all the weight models which are in the YOLO V8 will not be supported for the embedded applications like embedded boards like ZCU. Because of its heavy weights, we will convert it to the lower weights using the model conversion, and then the detected outputs will be given to two different tracking algorithms that will be tracked based on the its accuracy, and the tracked outputs will be given to the output frames. We can see the result of YOLO V8 plus ByTrack algorithm. That is, the detection is done by the YOLO V8 algorithm and the tracking is done by the ByTrack algorithm. We can analyze the tracking IDs by using the frame wise analysis. We can see at the different frames, different consecutive frames, the ID has been tracked for the person, and the YOLO V8 has capability to detect 80 different objects based on its training dataset, that is a COCO dataset. And it is able to detect the objects based, and it will give the confidence score also. Next slide. And the previous one. This is with the OC sort algorithm, and the same object detection model is used, and we can see the various objects tracked using the tracking IDs. Next slide. And this analysis shows the various cores utilization of the ZCU104 evaluation kit. We can see that different cores used as a uniform utilization by both the algorithms. Thank you.
Yes, good work,
Yes,
Rajwal. Yes, yes. What are the advantages of your work?
Ma'am, this work is mainly important in the case of low power devices, as the many of the devices where this type of detection algorithms and tracking algorithms run were high power devices, but the main intention is to deploy these systems on a low power devices like ZC104 evaluation kits.
And have you thought about future work?
Like future work will be like this algorithm taking too much time to load on the devices like FPGA. So we thought of quantizing it to increase the speed and accuracy.
Okay, good, good, good. Thank you.
Thank you, ma'am.
Thank you, sir, for your presentation. Now we'll proceed to the last presentation of today's session. So this is the very last presenter of today's session, Suparna Ray, ma'am. And the paper title is Research Trends in Technology for Achieving Sustainable Development Goals. Ma'am, I request you to start with your presentation.
Okay, all right. Can I share the screen? Share
Yes,
my
yes.
PPT, yeah? Okay. Visible, is it?
Yes, yes.
Yeah, okay. Okay, all right. Yeah. Good evening. I hope I would be able to do justice with our paper in this allotted time. Thank you for this opportunity. This is a working paper with our Dean, Dr. Raghuraman. He's Dean of our school as well as Amrita Puri, Amrita School of Business. And I, Suparna, Assistant Professor of Finance, and from Amravati, Amrita School of Business, and Sarvani K. She is also Assistant Professor of Finance Accounting from Amrita School of Business Accounting. Amravati. Okay, so what do we do in this paper? In this paper, we study how recent research trends in science and technology are facilitating the attainment of sustainable development goals. Now, what are these? Yeah, okay. So what are these sustainable development goals? As you can see from the screen, 17 a set of 17 sustainable development goals have been formally adopted by the United Nations in 2015, as you can see from these slides. And the formal adoption has led to an increased research focus on these on this topic. So what are the objective of these goals? The primary objective is to foster the overall well-being of humankind with a sustainable environment for every living creature on the earth. So it is not only humankind, but all other living creatures. And due to their multidimensional nature, the sustainable development goals are also interlinked with one another. As you can see from this slide, that quite a few of the goals are like, they overlap with the others. So that's what makes the attainment quite complex. And the United Nations Commission on Science, Technology and Science and Technology for Development, they have emphasized science and science, technology and innovation um, to be crucial for this SDG attainment, progress in the attainment of sustainable development goals. And although studies from multifarious disciplines have explored these SDGs, but actionable insights are still missing. So therefore, it is necessary to take a stock of how these research studies have evolved from both emerging and developed nations, and what has been their contribution in fostering development through achieving these sustainable development goals. So this is the backdrop against which we have begun our paper, started looking at examining the role of technology. Actually, there is no specific field of research for technology. So therefore, we've opted to use information and computing sciences as the variable or proxy for technology. And I mean, it is okay because it covers, like, information and computing sciences cover a broad spectrum of technological areas, for example, information systems, systems of software, etc. So yeah, so according to United Commission on Science and Technology for Development, they feel that the sustainable development goals without effective use of technology are impossible to achieve. And this is where we start our paper. So as I already mentioned, that our aim here is to, so just let me go to the research questions. Yeah, okay. So therefore, our research questions that you see on these slides basically focus on the publication, count of publication and citations. Now, why that is important? So here our research questions are looking at publication counts and citation counts over a period of 8 years. And as I was saying, so The publication and citation counts are important because this indicate that how the research community is treating the call for action on the sustainable development goals, which are the most researched ones with practical technological applications. And we also look at the impact of open access publications. What is their importance in fostering SDG research? Next, we look at research outputs from prominent fields of information and computing sciences, and we map them to the Sustainable Development Goals, which is our focus. And then we link them to the SDG related publications by major educational institutions. And finally, we examine which sustainable development goals are prioritized by the top funding institutions. So these are what we look at. Now, going briefly to our methods. Sorry, I skipped the literature review bit due to paucity of time. So our study is a bibliometric study. We use the PRISMA protocol, which is the standard methodology used for bibliometric studies. Period, as I mentioned before, an 8-year period from 2016 to 2023. Main database that we use is Dimensions database, which has a broader coverage of research papers broader than Scopus. And we use this VOS viewer software and digital sciences SDG mappings to get the insight on how the SDGs are mapped to the technology related papers. Next few slides, we talk about the results that we have got based on our research questions. So here they are. So as you can see, so our first research question, if we go back to our first research questions, publication and citation counts have how they have evolved over the number of years. As we see from 2016 to 2023, we see that the total citation ratio to total publication ratio has improved substantially from 2016 to 2023. Our second research question, where we look at how open access to research articles, how impactful it is in fostering SDG research. With respect to that, we see that the open access has so the same ratio. We looked at the total citation by is to total publication. So it is substantially more research impact for open access articles than the subscription based ones. And based on a third research question, we find that out of the 17 set of sustainable development goals that we have talked about, we've just mentioned on the second slide, only 3 have been extensively researched. And as you can see here, SDG 7, which is about affordable and clean energy, followed by SDG 3, which is good health and well-being, and number 4, which is about the quality education. So these are the most researched, these are the ones, these sustainable development goals have been the most researched using the technology. So the next research question that we had is how
Ma'am, extremely sorry to interrupt you in between.
we are about to finish.
Okay.
Yeah, so just give me 2 minutes. So the fields of research and their research performance, as we see here that theory of computation has the maximum potential maximum research output followed by machine learning. And the last one that we see here is that, sorry, I have one more. So we see that educational institutions from India and China are pioneering in respect of their technology-based sustainable development goals research, as you can see from this slide. And finally, if we look at the top funders, who are the funding institutions who and how their funding is aligned to SDG, we find a replication of what we have seen in respect of table 3, where we see that Sustainable Development Goal 7 has the most prominence. So here, in respect of funding bodies from China, European Union, United States, Japan, we see that Sustainable Development Goal number 7 has got the most prominence. So the last slide is about the result summary, all that we have just mentioned. So here we find that in our study, we find that technology has proved quite important in respect of fostering the sustainable development goals. Thank you.
Thank you, ma'am.
Yes, thank you very much.
Yeah.
Yes. So this is the review, whatever you have done.
Yes, this is a review study. Yes, bibliometric means a review study. Yeah.
Yeah. So what are your future plans about its implementation?
This is not really about the implementation. What we did was we were tracking how the research related to sustainable development goes, because the UN mandate, the United Nations mandate, is we need to achieve the sustainable development goals for the betterment of humankind by 2030. So in that respect, this is important, that how much we have achieved, what still needs to be done.
Okay. Thank you very much.
Thank you. So can I leave?
Just wait for a minute, ma'am.
Okay.
Yes, we'll start with the closing. So I sincerely thank our authors for the excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of the whole team, thank you for the support during the 8th version and all the previous 7 versions of the conference. We will be happy to have you in the 9th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with our team. I also want to thank our session chair, Dr. Varsha Zadho ma'am, for chairing the session. Thank you so much, ma'am.
Thank you.
Token of appreciation
Thank you.
to the chair on the behalf of our team, ICTIS 2024 and Global Knowledge Research Foundation and partners. Thank you all for your valuable presence. And before leaving the meet, there is one last request. Can you all please switch on your cameras so that I can take a quick snapshot of this session?
Okay. Okay. All right. Yeah. I think I'm visible.
Yes, ma'am, you are visible.
Okay. Thank you.
I request all other present participants to switch on your cameras. I think I've taken this snapshot.
Okay, great.
Everyone can leave the meet.
Share that snapshot with me.
Yes, ma'am.
Share the snapshot with me.
Yes, ma'am. I'll send you on. I have your number. I'll send you on WhatsApp.
Yes. Thank you very much. It was very nice presentation by all the participants. Siddhi, you conducted very nicely.
Thank you so much, ma'am.
Thank you. Thank you. Thank you very much. And thank you, Dr. Varsha. Thank you.
Thank you very much, ma'am.
Thanks.